Okay, so we're going to have a look at another question from the 2020 HSC Advanced Maths paper. HSC Advanced Maths paper. So this is question 30. So we're getting right to the end of the paper. This is probably the hardest question in the paper. So that very few students will actually get this right. It's 6 marks. The first bit is worth 2 marks. The second bit on the following page is worth 4 marks. This will be one of the questions that students have found most difficult. It's also calculus. Anything that's calculus often makes up the hardest questions, and it's right at the end of the paper. So we're told the diagram shows two parabolas. We're told that A is greater than 0. The two parabolas intersect at the origin 0 and a point A. Show the x-coordinate of A is 4 on A plus 1. Okay, so we know that we have two parabolas here. So this is question 30, part A. We have y equals ax squared, and we have y equals 4x minus x squared. So we need to find where they intersect. We're going to let this equal this. So we have ax squared is equal to 4x minus x squared. Now we're going to add x squared to both sides. We're going to minus 4x from both sides. So cancel this, cancel this. This will yield for us ax squared plus x squared minus 4x is equal to 0. Now this is a quadratic equation which we can solve. We can factor x out of everything on this side. So we get x times ax plus x minus 4 is equal to 0. Now this is true when this is equal to 0 and or when this is equal to 0. The first one yields that x is 0. That's the point where they intersect at the origin. This other one gives us ax plus x minus 4 equals 0. Add 4 to both sides. This gives us ax plus x is equal to 4. Factorize x. We get x times a plus 1 is equal to 4. Divide both sides by a plus 1. And we get x is equal to 4 divided by a plus 1. And this is the answer that we're after here. So the x-coordinate of a is 4 divided by a plus 1. And we showed this using quadratics. So this is the first part of the question. This is the easier part of the question. The harder part is find the value of a such that the shaded area is 16 on 3. Okay, so we essentially need the area to be 16 on 3. So the way we're going to find this is we're going to do an integral. We're going to say, so this is part B, we're going to say the integral from 0 to 4 on a plus 1. So this is the integral starts at the origin, then goes up to the x-coordinate of a, because that's the area. It will be the positive integral of the upside down parabola, which will be 4x minus x squared. And then we will be subtracting the integral of the positive parabola, minus a x squared, all integrated with respect to x. This integral must be the shaded area, which we've been told is 16 on 3. Now I've set this up very, very quickly. You could set it up as two separate integrals if you wanted, and you could do the two separate integrals and simplify it all down at the end. Here it's a bit nicer if we do it all as one integral. I am aware, however, that this is very hard for many students to do. So being sufficiently good at doing integrals to be able to identify that the area here could be thought of as a difference of integrals where the bounds and the function contain the unknown values, that is a little bit complicated. Right, so it's definitely not easy to do this all in one step, but if you can do it all in one step, now you just have an integral you're going to solve equal to a number. The only value unknown once you simplify the integral will be a. It will let you find the a value, and that's what we're after. Right, so this whole question is pretty much going to resolve itself if we can correctly do and evaluate this integral. So let's do the integral here. We have this becomes 4x becomes, let's see, 2x squared minus x squared becomes minus x cubed on 3. And then we're going to have minus ax squared will become minus ax cubed on 3. This is all going to be evaluated from 0 up to 4 over a plus 1, and the evaluation of this is all equal to 16/3. So now we have to do the the upper bound evaluation and the lower bound evaluation. Conveniently, the lower bound evaluation, the 0, sends everything to 0, so we can just forget about that. So this becomes 2 times 4 over a plus 1 squared minus 1/3 times 4 over a plus 1 cubed minus a thirds times 4 over a plus 1 cubed is equal to 16/3. So now we have an expression where the only unknown value is a. Now we just need to solve this. So what we'll do is we'll try and group everything on the left-hand side together. So if I expand this a little bit, I get 4 squared is 16, 2 times 16 is 32, 32 over a plus 1 squared, minus 4 cubed, 4 times 4 is 16, times 4 is 64, so this will be minus 64 over 3 times a plus 1 cubed, minus 64a over 3 times a plus 1 cubed is equal to 16 on 3. Now, because I have a 3 in the denominator, I can pretty much multiply everything by 3 and then just get rid of this 3 straight away. This is quite convenient. This goes, this goes, this goes. 32 times 3 is 96. I also need to multiply both numerator and denominator of this first term by a plus 1. This will give me 96 times a plus 1 over a plus 1 cubed minus 64 minus 64a is all equal to 16. So in this numerator, if we expand this, we have 96a plus 96 minus 64 minus 64a over a plus 1 cubed is equal to 16. 96a minus 64a is 32a. 96 minus 64 is 32. This is all over a plus 1 cubed. Now at this point, this is still equal to 16. I can factorize in the numerator, so I'm going to get 32 times a plus 1 over a plus 1 cubed is equal to 16. I can divide these both by 16. So this becomes 1, this becomes 2. I can cancel this a plus 1 with one of these a plus 1s. This gives me 2 over a plus 1 squared is equal to 1. Multiply both sides by a plus 1 squared. I get 2 is equal to a plus 1 squared. Square both sides. Take the square root of both sides. This gives me a plus 1 is equal to plus minus the square root of 2. This will just be plus root 2 in this case, because we have a square root of 2, and then we have a square root on the other side. So this will give us, we'll have a plus minus root 2. And then we'll minus 1 from both sides. This will give us a is equal to plus minus square root of 2 minus 1. However, we were told in the question specified for us that a was greater than 0. Right at the start, it says a is greater than 0. So this means that the answer we're after is root 2 minus 1. Can't be minus root 2 minus 1 because that answer would be negative. And so that would render the condition a being greater than 0 as impossible. So now let's have a look at the marking. So there's a lot of working here, and you will have a lot of working in a question like this. This is one of the hardest questions in the paper. The first mark for question 30a, you'll have to attempt to solve the quadratic equation to find next coordinate or equivalent merit. So something like this. This part of the question will get you a mark. Getting the value x is 4 on a plus 1 with correct working will get you the second mark. The next part is worth a lot of marks. To get a first mark, you'll have to write an expression for the area involving an integral of the difference between two functions or equivalent merit. So something like this setup is going to get you the first mark. Finding an antiderivative is going to get you a second mark. So continuing the working here. Correctly substituting the limits into the antiderivative or equivalent will get you a third mark. So in this case, this will be, we'll have a little bit of working here as well. And then for the fourth mark, you'll have to provide the correct solution. So that will actually take us all the way down to the end here. And the marking centers internally will decide specifically what they think is sufficient working to get 1, 2, 3, or 4. Here, to get all 4 of these marks though, you need pretty much all of this. You don't need as many steps as I've done. I've done a lot of steps here. I tend to prefer more steps rather than less. It tends to confirm for me exactly what I'm doing. I would prefer not to take too many risks with my working, but if you want to take more risks with your working, you're free to do so. So this is how this question works. This is probably the hardest question in the paper.